Hi, I'm Manoli, lead 3D artist at TDC, and welcome to part 2 of our Blender 5 hard surface modelling instructional video. Today we'll be looking at another hard surface prop that was modelled in-house using another one of our hard surface workflows. The technique we're exploring today is relatively fast and gives clean results with organic shapes that need hard surface detailing. This is suited to any size 3D models, from small props like hard surface wearables such as body armour, all the way up to spacecraft and vehicles. This technique can be used in combination with other hard surface workflows such as shader corner beveling or subdiv modelling. It's sculpt based, and combined with the power of procedural materials, the workflow will also deliver models that are perfect for real-time projects, once the high definition details are baked into the retopologized mesh. This technique requires a larger poly count on the high definition object in order to have enough polys to sculpt in details. Let's first have a look at the high definition model before the sculpting pass has been added. Here we have the base mesh for what will be a helmet. The dimensions are to scale and it's ready to have details sculpted in. Notice that this mesh has a good base poly density, with an even spacing of faces and generally neat mesh. Good loop placement, no n-gons and no verts with more than 5 edges is important for sculpt details to be consistent on the mesh surface. Once the mesh is ready to sculpt, add a multi-res modifier and subdivide enough times to ensure the details will be clear when sculpting. For our model, we went with 5. Now let's switch to sculpt mode. Hard surface sculpting can be tricky, but a good place to start is with masks. Coupled with stroke methods such as line or curve, shapes are able to be plotted out less destructively and can be checked from different angles before committing. The line stroke method can be used to draw straight lines, and the curve stroke method can be used to draw curved lines. Make a curved point by right-clicking whilst holding Control. Drag the mouse before releasing to adjust curve handle length, and therefore softness of the curve. Press Enter to create the curved line in the mask. The thickness of the drawn line is determined by the brush size, and can be altered with the F key and mouse drag. The Polyline Mask tool can be used to fill in panel areas. Control-I can be used to invert the selection so that mesh adjustments can be made in the sculpt. Mesh Filter can be used to extrude or contract the selection. This can be handy for adding panel cuts with a consistent depth. Another way to add panel cuts is by using the layer brush. This will draw at a consistent depth provided that persistent is checked in the tool menu of the brush. The Set Persistent base button must also be clicked, and the brush strength needs to be set to 1 for this to work. Using these techniques we can add hard surface details and make the shape much more interesting. After sculpting is complete, the high definition mesh is ready for material setup. For the next step, we'll need to unwrap the sculpted mesh. Switch to the UV editing tab and enter edit mode. Notice that the multi-res modifier will revert the mesh to the base level while UV editing. Divide the object up into UV islands by selecting and therefore defining the edges of the islands. Mark them as seams. Once the islands are set, select all faces in edit mode, and in the UV menu, select Unwrap Angle Based. Adjust margins and spacing to suit, being sure not to overlap any UVs. Let's switch to the Texture Paint tab. In the Texture Paint tab, image masks can be drawn similarly to sculpting masks. In the HD material, add a new non-color image. The larger the resolution, the clearer the mask edges will be. In our case, we chose a 4096 by 4096 sized image. Once created, select the image in the material and switch to the Texture Paint tab. Draw in the masks using line and curve stroke methods to define where different shaders will be displayed on the mesh. Since we have 3 different surfaces, and hence 3 different shaders to display in the material, We will need two masks, one showing where the orange coloured surface will go, and then on top of those other two shaders, another, to assign where the glass visor material will go. This could be done with one image using red for one shader and green and blue for the other two shaders, and then separated using a separate RGB node. But for the sake of simplicity, let's just have two separate grayscale images. In the Mix Shader node, plug these masks into the factor to apply different shaders to different parts of the mesh. Each shader has its own ambient occlusion and edge wear being procedurally generated, so when the high definition mesh is baked down, it will also inherently bake these details in, similarly to how our model from Part 1's material worked. Once the high definition model is ready to be baked to a low definition model, it's time for retopology. Let's look at our low definition model. This prop in particular is for a real-time top-down project using Xbox 360 era constraints and poly budgets. Our retopologized model should maintain the detailed enough silhouette while staying under 3000 tries. We were able to get our low-definition model down to around 2700 tries, which was enough to give the 3D model a solid silhouette. It's important to follow good 3D modeling practices when at this retopology stage, and creating the mesh that will be used in real-time projects. Quads only with minimal tries and 3 edge vertices are industry standard, and GODs should also be avoided. When the low definition mesh is finished, a weighted normal modifier should be added. Set the weight to 100, check keep sharp and face influence, and keep the threshold at 0.01. Apply the modifier. Once the low definition mesh is modelled in, it can be unwrapped. Let's look at our low poly UV layout. Divide the object up into UV islands by selecting and therefore defining the edges of the islands. Mark them as seams. Once the islands are set, select all faces in edit mode, and in the UV menu, select Unwrap Angle Based. Adjust margins and spacing to suit, being sure not to overlap any UVs. Our UV islands are sized to be 3.5 pixels per centimeter with a 512 pixel map. Objects should always be baked from higher resolutions, however, so we'll be baking this at 2048 by 2048 pixels. As with the last part in this series, using a cage mesh to bake details is ideal for this process, and can be used as a visual guide. To make the cage, duplicate the low definition mesh, remove materials, and add a displacement modifier. Set the mid-level to 0. A suitable strength is relative to the size of the model. For our model, a strength of 0.006 was sufficient. Apply the displacement modifier. Any mesh that folds in on itself should be relaxed, and no part of the low definition mesh should be outside of the cage mesh. Select all of the high definition objects, and lastly, the low definition model. Now click Bake via the Bake menu in Render Properties. Our model uses a base color, roughness, metal, and normal map, which will store the sculpted details from the high definition model. Be sure to bake the normal, roughness, and metal maps to a non-color image, and set HD materials to 0 metallic during the bake process. Once the materials are applied, this model is ready for real-time or rendered use. In our case, this will be used in the Godot engine. Even more detail could be added into the material procedurally or manually. Since this is for a top-down game, we kept it simple and easy to decode visually. We hope you liked this instructional video. Please consider leaving a like and subscribe. We would love to hear if you're interested in more TDC workflow videos like this, and any suggestions for future videos would be greatly appreciated. Thanks.